These notes are going to be on the periodic table. So we're going to put our heading up at the top. And the first thing we're going to talk about is a particular square in the periodic table. So if we look at nitrogen, okay, so we have a square in the periodic table. This is nitrogen. You can see you have a 7, an N, nitrogen, and a 14. So if we were to label these parts, the 7, because it is the smaller number, is the atomic number. The N is the symbol. Nitrogen is the chemical name. And 14 is the mass of the nucleus. It's considered the atomic mass. And so these are the protons, or this is the weight of the protons plus the neutrons. And the atomic number is just the number of protons. But since protons equals electrons, the positives equal the negative, it also tells us the number of electrons. Now sometimes, especially like on an SOL, you might see the square set up like this because they're trying to trick you. Where they're going to put 14 up at the top and 7 down at the bottom. It's still 7. I'm going to use my lightsaber here. Okay, 7 is still going to be the number of protons because 7 is the smaller number and 14 is the more massive number. So if you remember, 14 is the biggest or most massive number because this is the protons and the neutrons. This is just the number of protons. So obviously this is going to be a smaller number. So 7 is the atomic number, 14 is the atomic mass. And sometimes they'll switch those numbers. There's really no required way of setting a square up in the periodic table. You just have to know that the bigger number is the atomic mass. And then of course we're going to remember the following. That protons equal the electrons. Okay, that's the top half of your page. If you took up more than the top half, you're welcome to turn the page over and add a page if you need to. It's totally up to you. So in the middle of my page, we're going to talk about the way the table is set up. So now we're going to slide the page up. Okay, and we're going to go and we're going to talk about the table. So we're going to draw a rough sketch of the table that basically if we remember, kind of looks like a castle. Your lines don't have to be straight, as my lines are not either. And we're going to remember that the rows are called periods, and there are 7 periods on the periodic table, and you have 7 class periods a day, and they range starting at 1, then there's 2, then it goes down to 3, 4, 5, 6, 7. Okay? And then we have groups or families. And a group or a family is a column in a periodic table. Okay. And we're going to remember, and everything in a family is going to have similar characteristics. So everything in this column, like a family tree, is going to have similar characteristics. So if we want to think of it as more of a family pine tree, okay? And so we're going to write ourselves a little reminder that elements in a group or a family have similar properties. And then we're just going to put ourselves a little note right here just to remember the father of the periodic table is Mendeleev. Okay. And then at the bottom of the page, we're going to talk about valence electrons. And this is kind of really important because it helps you identify or make sure that you have the right number of electrons in the outermost shell. I'm going to scroll to the bottom of my page, but if you need, feel free to turn over your page if you need to. Okay, now we're going to talk about valence electrons. Okay, so valence electrons are electrons in the outermost shell of the atom. So if we're making Bohr models with rings or orbitals around the nucleus, the valence electrons are going to be the electrons in the outermost shell. So for instance, if I were to make a Bohr model of lithium, and lithium has 3 protons and 7 atomic mass, so it would have 3 protons, and that means it has 3 electrons. So 2 electrons in the first shell and 1 electron in the outermost shell. And this guy is going to be your valence electron. Okay, and just to complete this, we have 4 neutrons because the total mass of the nucleus needs to be 7, and so 3 plus 4 is 7. Okay, so we're just going to draw a little picture of our periodic table, another sketch of it, so it doesn't have to be a perfect sketch. Sorry, my pen keeps snagging on the screen. And the first column is going to have 1 valence electron. That's why hydrogen is in this column. The second column is going to have 2 valence electrons. We are going to skip the transition metals. You'll figure those out in chemistry. We have 3 in the 13th column. So it goes 1, 2, 3, 4. It goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then it's 13, 14, 15, 16, 17, 18. So in the 13th column, there are 3 valence electrons. There are 4 valence electrons in the 14th group, 5 valence electrons in the 15th, 6 in the 16th, 7 in the 17th, and 8 in the 18th, which is going to be your noble gases, which are the most stable. So 8 valence electrons are the most stable. Okay. Now on the back of my page, which could be venturing into another page for you, we're going to do just a couple of Bohr atomic models as a reminder, and we're going to do an electron dot diagram. Okay, so our first one we'll make a atomic model for is, we'll do nitrogen. Okay, so if we look at a square of nitrogen, it has 7 atomic number and 14 atomic mass. So if we were to draw a Bohr model, that would be our nucleus. We have in our nucleus 7 protons, 7 positives. That's number 7. And then we're going to have, because if we look at the periodic table and we look at where nitrogen is, nitrogen is right about here on the periodic table. It's in the second period. It's in the second row. Well, since it's in the second row, it's going to have 2 rings because it's in the second period. So that's going to be, we figure out it has 2 rings based on what row it's in. We also know that it's in the 15th family, or the 15th group, which means it has 5 valence electrons. So there's going to be 5 electrons in its outermost shell. 1, 2, 3, 4, 5. Now, there's 7 total because there's 7 protons, so we're going to put 2 in the first shell because the first shell can only hold 2. So 1, 2, 3, 4, 5, 6, 7. And then we know that the neutrons are going to be determined by the mass, which it has a mass of 14. And so if it has 7 protons in it, that means it must have 7 neutrons because 7 plus 7 is 14. So the valence electrons was determined by what column it was in, but we could also count. We know that in the first orbital there's 2, and that in the second orbital can hold 8, and so 5 are in the second orbital. Now to do the electron dot diagram, you will have an N, which is the symbol for nitrogen, and you'll have 5 dots representing the 5 valence electrons. And that's the electron dot diagram for nitrogen. So then we're going to do sodium. It has 11 as an atomic number and 23 as its atomic mass. If we look at it on the periodic table, sodium actually resides right here. It's in the 3rd period. So that means when we do the dot diagram, the Bohr model, it's going to have 3 rings because it's in the 3rd row. We also know that it's in the first group, the first family, which means it has 1 electron in its outermost shell, 1 valence electron. Okay, so we look, it has 11 protons, so it has 11p. That means it has 11 electrons, 2 in the first orbital, 8 in the second, and 1 in its outermost shell. So that's 10, 11. And then to look at the protons are determined by the atomic mass, which is 23, 11 of which are protons, making 12 neutrons. There are 12 neutral neutrons. We'll do one more. We'll do carbon. Carbon has an atomic number of 6, atomic mass of 12. So if we look for its position on our sketch of our periodic table, carbon is right here in the 14th group. It is in the 2nd period. So it has, if you were to draw a Bohr model, it'll have 2 orbitals because it's in the 2nd period. So it has 2 orbitals. It's in the 14th group, which means it has 4 valence electrons. 1, 2, 3, 4. I know that carbon has 6 protons. So it has 6 protons. It has 6 electrons, 2 in the first orbital, 4 in the second orbital, 1, 2, 3, 4, 5, 6. And it has 12 total neutrons. I'm sorry, the total mass is 12, so that means it must have 6 neutrons because 6 plus 6 is 12. Now if we were going to make a dot diagram of carbon, we would have its symbol C, and it would have 1, 2, 3, 4. Back up to sodium, if we were to do its dot diagram, it has 1 valence electron, so it just has 1 dot. And that's all we have for today's doodle notes.